just came in. I'm sure that's yours. Yep. Okay. Looks like we're doing some three-dimensional geometry.
Yes, we are.
Whoops, expanded it too much. Where would you like to begin, Hayden?
1A.
Okay.
All of it's a little confusing for me, so.
Find the volume of each composite space. By the left side and the right side, they mean 1A and 2A?
Yeah.
Or do they mean 1A and 1B?
I think.
They might mean 1A and 1B. I don't know. I don't suppose for us it matters. Okay. So, if we look at 1A, we can break this up into two solid rectangular blocks. There's one of them. Okay.
Yeah.
Tell me the dimensions of that block right there. In fact, tell me the equation for volume. What's the volume of a rectangular block?
A rectangular prism is the volume. Volume equals width times height times length, or length times width times height.
Yeah, it's the three dimensions. So for this thing that I've labeled number 1 here and I've circled, what is its volume?
18.
Well,
right?
What is this distance right here that they don't specifically put on there?
3.
Okay, so we have to do that first. Just come up with that 3. And now, what is it?
54, right?
And that's 54 cubic inches, or 54 inches cubed, either one. Now, how about this block here, number 2? What are its 3 dimensions?
7, 5, and... Wait. Yeah. 7, 5, and... Wait a second.
All right, what's this dimension?
Which one?
This one right here? Here, I may have confused you by putting this number 2.
Oh.
Okay, we're dealing with this block right there.
Yes.
Okay, what's that dimension?
5 inches.
What is this dimension?
7 inches.
Okay, there's only 1/3 dimension that we haven't covered, and that's this dimension. What is that?
Oh, it's 6.
Okay. So it's 5 times 7 times 6. What is that in your calculator?
210.
So we have to add those two together. And we come up with 264 cubic inches.
64.
And that's basically the way we're going to do all of these. We're just going to break each object up into, in other words, this one right here, I'm going to make it a tetrahedron, or whatever that top is called, and a cube. Or not a cube, but the bottom part's a rectangular block. So I'm going to do the same thing with that. Okay. Now, let's deal with the easy part first, which is the bottom, this part.
Mm-hmm.
The floor of
Okay.
this tent is a square. So we're going to do the volume of the cube.
Okay.
What three dimensions is that going to be?
10, 10, and 8.
Okay.
10.
So that's 800. And that is cubic feet. Now let's look at that thing. How do we figure out the volume of a four-sided pyramid, a square pyramid?
Length times width times height divided by 3.
Very good. So what is this?
6 times 10 times 10, which is 600.
Divided by 3.
Divided by 3. 200.
One way to remember that is anytime you have something that goes to a point, it's 1/3 of the volume that it would have been if it would have been a full cube.
Okay.
And that's true whether or not it's a cone or a pyramid like this or a pyramid with a six-sided base. It does not matter. It's whatever the area of that prism would have been divided by 3.
Okay.
It's just a handy way to remember.
All right.
So the total volume of that is 1,000.
Mm-hmm.
Now, the more difficult problem with some of these is surface area. Volume's actually pretty easy because we can break every single figure we're looking at into 2 figures, and we know the dimensions of both of those figures. So is this whole test about volume, not surface area?
No, it's volume and surface area.
Okay. These first couple questions were volume only. Are we going to get surface area along with it? Because I don't see surface area questions.
I think this one's just volume, but I think we could probably do surface area too, because I really need help with that one too.
Let's do surface area.
Okay.
Because it's a little trickier. Let's go back to 1.
Yeah.
Okay.
Okay.
The surface area is every outside area that you can see. Again, hold on, excuse me. In other words, again, we're going to break it up into areas. And now if we look at this bottom one, we've got 1, 2, 3, and then that side there that's invisible to us, 4, and then the bottom, the 5th side, which is underneath, which is invisible to us. Now, normally a rectangular block would have 6 sides. The reason this one only has 5 is because the 6th side is closed to us. It's not visible. It doesn't count as surface area. It's not surface. It's inside. In other words, the side that would have been opposite this side right there.
Yeah.
Okay. So there's only 5 surfaces in that one. So let's call them 1, 2, and 3, the top and the bottom. 4 and 5, the left and the right. You with me?
Yes.
Okay. What's the area of surface area 1?
Wouldn't it be 6 times 3?
18.
So 18.
That is square inches. Surface area. Area is always in square. Okay. How about surface 2?
It'd be 18 as well.
Yes. And there's actually two. Yeah, it is 18, but area 2 and area 3 is the same, right?
Yes.
Okay. Now let's do area 4, which is the same as area 5. We could just do 2 times area 4, but just to be real clear, what is let's look at 5 because we can see that. What's that surface area?
Okay. 9.
Okay. So that's 9. That means 4 is also 9. So there's our 5 surface areas.
Okay.
Add those up. It should be 4 times 18, 72 square inches is the surface area for that object. Now let's let me erase what I've drawn on here. And let's deal with the bigger rectangular block.
Okay.
Okay. And this time we have surface area 1, top and bottom, right?
Yes.
So I'm going to call that surface area 1 and surface area 2. And then we have 3, that side and this side, 3 and 4. And then we have 5, which is unique. And then we have 6, which is this back one, which is unique. Okay?
Okay.
Let's go through the same exercise. What's the surface area of 1, the top?
30.
Okay. And there's 2 of those. 1 and 2 are the same, right?
Yes.
2 is just the other side of that block. In case you're having a hard time reading my thing here. 4 is this side, as well as its opposite side, which is 3. So what's that area?
56.
Both of them. And notice there's only one that's surface area 5. That doesn't have an opposite side that's the same dimensions. So what's the surface area of 5?
24.
Huh? And finally, the surface area of 6, which is this back face that's invisible. That face right there.
42.
And there's only one of those. Now add up those numbers, and you get the outside surface area of the second block. Add that to the surface area of the first block, and you get your total surface.
I got 238 with my test.
Yeah, I'm not checking your math, so that actually doesn't sound right. That's 60. That's 172, 196. That's 238 plus 72.
60 plus
310 is the total.
Okay.
Yeah.
Yeah, I got that the second.
I thought you were saying 238 for the whole figure. But so that's how we do surface area, and you can see that it was harder. It was quite a bit harder.
Yeah.
We didn't have, when you do surface area on just a cube, it's relatively easy because you know there's 6 faces and there's only 3 unique faces, and each one of them you multiply by 2. So it's not so hard if you're working with a cube, but when you're working with a strange shaped figure like this, it's a little harder. Now,
can we try to do the volume and surface area of 3A?
Sure. scroll down up. Again, we're going to separate it into two figures. Let's talk about volume first. What is the volume of this object? What's the volume of the bottom? What's the volume of the right cylinder?
Like the formula?
Yeah, always start with the general formula. That's a great place to start.
Pi times radius squared times the height.
Okay. So what is that? 30. What's 36 times 8?
Let me check. 288.
Okay, in this case, it's 288 pi. And I did notice the instructions said to use 3.14 for pi. So if you want to go ahead and multiply that out, normally in geometry, you don't do that. You leave it in terms of pi. But since her instructions, or his instructions, specifically say 3.14 for pi, go ahead and substitute that. Don't hit the pi key, but multiply 288 by 3.14.
904.32.
Okay. And that again is cubic meters. Now let's talk about the volume of the top. That's a cone.
Yes.
So that was the volume of the cylinder. If I want the volume of the cone, what's the general formula for it? It's a person goes to a point.
Pi times radius squared times height divided by 3.
Good. It's always 1/3 of what the prism would have been. So in this case, it's still 36. What's 36 times 7?
252.
252 pi divided by 3. Let's come up with that number also. 252 times 3.14 divided by 3.
I got 263.76.
Now, if we do just a visual check to see whether that makes sense, are we in the ballpark? Does that volume sound appropriate for the figure we're looking at? Clearly, the volume of the cone's got to be less than the volume of the cylinder, right?
Yeah.
Is it?
Yes.
Yeah, by just about the right amount. So now we add these two together, and that's the volume of that whole thing.
1,168.08.
Okay. Now, let's talk about surface area.
All right.
Again, we're going to break it up into a couple of things. The first surface, we're going to start from the bottom and go up. First surface is at the very bottom. Even though it's hidden, it still counts as a surface because it's facing the outside.
Okay.
What's the surface area of the base? Pi r squared.
Hang on. 36. 113.4, I think.
Now, the next thing, there's no top. That top is hidden. That faces the inside. So we've taken care of the bottom. The only other thing is the surrounding, the lateral surface area. In other words, the part that goes this way, around the thing. What's the area?
Okay.
This is a little tricky, but you have to use it repeatedly in geometry and higher maths.
Would it be 2 times pi times radius times height? I don't know. I was just...
You're close. That's not bad. First of all, assume that that's a label around a juice can.
Okay.
If I peeled that label off, it would be a rectangle, correct?
Yes.
What's the height of that rectangle?
8 meters.
What's the length of that rectangle?
How would you find the length of the rectangle?
The circumference of that circle. 2 pi r. 12 pi. That is the length of that label. In other words, the dimension from here to here is the circumference of that circle, right? That label fits around that cylinder just perfectly. So if we're trying to figure out the surface area of that lateral surface area of that cylinder, then we want the area of this rectangle, the label that would peel off. And that's 96 pi. So what number is that?
301.44. 44.
Okay. Now the toughest part, and the only part left, which is the surface area, the lateral surface area, you know what I mean by lateral, of the cone, the hat. There's no base to that hat. It's hidden also. So the only thing we need is this. What's that?
Sorry, what was the question? It cut out for a second.
We need the lateral surface area of that cone.
Yes.
Do you have a formula for that?
Oh, we don't. That wasn't part of like the sheet that we were given.
Well, I'm not 100% sure, and I'm gonna look it up, but I think it is 1/2 lambda, which is the lateral distance from there to there, times pi. Okay, but I want to look that up before I give it to you, because
Okay.
although I don't know that we want to spend time on this, because it doesn't look like you're going to be tested on surface area, but maybe. Let me just get that formula for you quickly here. Let me turn to the right page. Almost did. Surface area of cones. I can't find that formula. Must have skipped right by it. Excuse me a moment. Finding the surface area of a sphere. That's 4 pi r squared. Volume of a sphere was about to give me the surface area of a cone, and it skipped right by it. And it's a strange surface area formula. That's why I'm not remembering it exactly, because it has this lambda in it. Oh, here we go. Nope. Yeah. Oh, here we go. It's pi r squared plus pi r lambda. I was almost right. It's pi r lambda. It's not 1/2. Okay? Now, we don't know lambda, but we do know we're looking at a right triangle, like that. And this dimension is 6. This height is 7. What's lambda? Well, that's the square root of 49 plus 36. So that's the square root of 85. Okay, so the surface area of the top part is square root of 85 times pi times 6. Add that to the surface area of the bottom cylinder, and you have the base. In other words, you're going to add 36 pi to 96 pi to that number there. And that's going to be the surface area of that whole object. The biggest thing about surface areas is just make sure that you only count the areas that face outwards. Like on this house here. This top area right there, that does not face outwards anywhere. It faces up, it faces down. But so that's not going to be part of the surface area.
Okay.
You know, you would have that side, you'd have this side, you'd have this face, you'd have that face, and you'd have the bottom base, and you'd have the 4 sides around the bottom rectangle block. But that's basically how you're going to do all these problems, is you're going to break them up into objects where you know what the volume is of that object. You know how to figure out the volume of a cone, or the volume of a right cylinder, or the volume of a rectangular block. So that's the concept. Okay?
Okay. Well, thank you so much.
You're welcome. I got to let you go just because I got a 4:30 also here. So,
okay.
Have a good day. Good luck on your test, and I'll talk to you next time.
Okay, thank you.